Alrighty, musician has a new song available for downloading or streaming. You earn 9 cents every time you download it. So 9 cents goes with downloading. Then you have 0.002, so less than a penny every time it's streamed. Which of the following represents the amount in dollars that you earn if the song is downloaded D times? So D is going to go with the download part. And stream is S. That's going to go with the streaming money. And so the total amount, I collect money when both of those happen. So I get 9 cents times every download plus 0.002 times every time it is streamed, and that matches up with C. So B and D do not make sense because there's a subtraction sign in there. You would not subtract those two, you would add those together. And A is wrong because the money, the two number parts are mixed up. You're getting 9 cents for a download and 0.002 for streaming, not vice versa. So that one was just backwards. So correct answer is C. Number 2, a quality control manager at a factory selects 7 light bulbs at random out of every 400. At this rate, how many light bulbs will be inspected for 20,000? So to me, this kind of looks like a proportion problem. There's probably several ways to do it. I'll try to show you a couple of them. So I'm checking 7 out of every 400. All right, so that's a ratio, that's a proportion. And at this rate, meaning if I keep that rate the same, how many light bulbs, so how many am I going to inspect out of 20,000 being produced? Now there's kind of two ways to solve this part. You could cross multiply. I could go 400 times X equals 7 times 20,000, which is 140,000. And then we're going to divide both sides by 400, which should give me a correct answer of B, 350. So that's one way you could do it. Another way, without going through all that, is you might have been able to look at the denominator right here and saw that it was just a multiple. Basically, if I kind of get rid of these zeros here, I see that 4 times 50 would get me to the 200 there. And whatever I do to the bottom, I have to match on the top. So that might have been a faster way without a calculator to get the answer of 350. That could work. There's some other ways using percents that could work. I probably wouldn't do them this way, but you could have used 7 out of 400 and found what percent that was. So when I divide 7 by 400, I get 0.0175 or 1.75%. And then I could have used that number, 0.0175, and then just multiplied it by the total, by 20,000. I probably wouldn't have done it this way, but it also could work. And you get 350 that way. So a couple different ways there to do number 2. Number 3, one end of a spring is attached to a ceiling. When an object of mass M is attached to the other end of the spring stretches to a length of L. What is M when L is 73? So I probably don't really have to have a picture, but I'm going to draw one just so you kind of know what's going on here. So you have a ceiling, and you have some sort of a spring with a mass attached to it. So this is your mass. L is the length of the spring that's being stretched. So there's your length. And then you have an equation here that relates the two. This equation, kind of for any mass, you can just plug it in there and you can find the L. So these equations are nice. This is a linear equation because if you tell me the mass of something, I can then solve it for the length or vice versa. So it says, what is the mass, what is M, when L equals 73? So I'm going to basically just fill this in the equation. When L is 73, we're going to solve it for the mass. And whenever you want to solve a linear equation, you basically want to isolate the variable. I want to get M by itself. So I'm going to subtract this 24 from both sides, which comes out to be 49 equals 3.5 M. And then to get that M all alone, I'm going to divide both sides by 3.5. Divide by 3.5, 0.7, 0.5. And I know 3.5 goes into 7 twice, and then 7 of those, so it's looking like 14. So the correct answer here is going to be 14. Now, I strongly suggest you get good at solving linear equations because there's a lot of them on here. But if you were in a pinch, you could also just kind of plug these numbers in. If you want to find out M when L is 73, you could plug in the two numbers. You could say, hey, well, 73 equals 24 plus 3.5 times, and then you would just start trying each one of these numbers until you got a true statement. Luckily, the very first one that you plugged in, if you plug the 14 in there, this one would actually work out, and it would work for you. So the correct answer would be A either way. All right, 4 and 5 kind of go together, so I'm going to do these two kind of all at once. But they're operating off of the same information. So it says the amount of money a performer earns is directly proportional to the number of people attending the performance. The performer earns $120 when 8 people attend. So, you know, right away, my mind kind of looks at this thing and kind of says, well, I guess I could find out a per person amount if I wanted to. You know, if I get $120 divided by 8 people, that comes out to be $15 per person. Now, I don't know if I'm going to need this, but my mind kind of just went that way, so I wanted to figure out how much that was per person. So number 4 says, how much money will a performer earn when 20 people attend? Well, because of what I just did, we could say, well, if I have 20 people multiplied by $15 per person, you know, that's going to come out to be $300. So that would be one way to solve this one. Another way to solve that one would be to set up a proportion. I'm really big on setting up proportions. I kind of like doing them that way. So you could also say, I make $120 when 8 people show up. So how much money am I going to make when 20 people show up? It's a little bit longer to do it this way, but you'll always get them right. You cross multiply, that's how you solve a proportion. You'll get 8x equals, what's that, 2,400? And divide both sides by 8, bam, bam. And it looks like x equals $300. So either way, C would be the best bet. Let's kind of move on down. Let's tackle 5 since it goes right with this one. It says the performer uses 53% of the money here to pay the costs. So 43% go to costs. The rest of the money is the profit. What is the profit? So that's big. They want to know, what is the profit you make at a performance where 8 people attend? Well, so we already figured out from up above, when 8 people attend, that is $120. So I kind of have a couple numbers here I could look at. My costs are 43%, all right, which means since it has the total 100, my profit has to be 57%. So I basically get to keep or profit 57% of the $120, which is more than half. You know, so I know right now these two answers are out because they're less than 60. 60 would be half. So I'm more than half. Now the shortcut to doing a percentage of a total is move it 2 places and turn it into a decimal. So 0.57 times 120. Correct answer there is going to be C. It's going to come out to be $68.40. So correct answer there is C. Another way that some people like to do percentages, they like to use the is over of equals percent over 100. This way you don't have to change a percent to a decimal, but basically you're looking at like the part out of the whole. So somebody may have set this one up and say, well, 57% of 120, so my of is 120, my percent is 57. 100 always goes there because that's what percent means. It means per 100. And then you'd have to solve for x. And you would cross multiply and get the answer that way. Much faster, much easier to just learn this shortcut and use it. Number 6 looks kind of like an algebra, like a verbal expression problem where you have to translate it into an algebra equation. So it says when 4 times a number x, so 4 times x, you could put a dot there, but you really don't have to, is added to 12, the answer, the result, is 8. Okay. Then it says what number results, so this is a kind of a separate clue, what number results, or what is the answer, when 2 times that number is added to 7. Well, this is like a solve-resolve. We're going to use the first equation to find out what x is, and then we're going to plug it into the second one. So in this first equation to solve for x, I'm going to subtract 12 from both sides, which means I'm going to have 4x equals negative 4, and divide both sides by 4, and I find out x equals negative 1. Well, be careful. Do not choose negative 1. They do this all the time. They try to trip you up. They make you solve the first one. You're in a rush, and you look over and see the negative 1, and you circle it. But we didn't answer the second part. What about when we take that number and we jam it in the second equation? So 2 times negative 1 plus 7, well, that's a negative 2 added to 7 is positive 5. So the correct answer is actually B. Most common mistake there would be to choose A after solving the first equation. Number 7 looks like we have a quadratic. I know it's a quadratic because I see an x squared term here. So it says the equation above represents a parabola. Remember, a parabola is just a bowl going up or down. Which of the following equivalent forms of the equation displays the x-intercepts? So remember on a graph, if you have this, I'm just going to kind of put this maybe over here somewhere, but the x-intercepts would be where it crosses the y-axis, okay? Where it crosses the x-axis, I mean. So the ordered pair, the x-intercepts, are going to be something comma 0 and something comma 0. So basically your y value is 0. So what I can do is I can set this thing equal to 0, and I can solve this equation. When y is 0, what is x going to be? And I have some separate videos on factoring and different ways to solve quadratics. Sometimes you have to factor, sometimes you have to use quadratic formula. This one's factorable. I'm going to try to kind of do like reverse FOIL, if you've heard of FOIL before. But I'm going to try to get 2 expressions at times together to make that. So the front 2 terms make this piece. So the only way to get x squared is x times x. Now here's where it gets a little bit tricky. My back piece, I need to find 2 numbers that multiply to make positive 8. But then these 2 numbers have to add together to make negative 6. So I got to multiply to make positive 8, add to make negative 6. And, you know, I don't see any way with 1 and 8 to get there, or negative 1 and negative 8. You know, those multiply together to make positive 8. I don't see a way to get negative 6 out of that. But I think that if I do negative 2 times a negative 4, I think that will give me what I need. Because when I do my FOIL, you know, x times x will give me my x squared. I have a negative 4x and a negative 2x for my outside and my inside terms. That gives me my minus 6x. And then my last times last, negative 2 times negative 2, or negative 4 I should say, gives me positive 8. So I now have these 2 factors, x minus 2 and x minus 4. And what I've effectively done is I've figured out that this parabola is going to cross, and you don't really need to know this piece right here. Right now the answer is D. But what I'm showing you can help you out in other problems. What this tells me is, this tells me this parabola is going to have solutions at x equals 2 and x equals 4. Because when you plug 2 in here, you'll get 0 times, you know, negative 2, which comes out to be 0. And if you plug 4 into this one, you'll get 0 on the right, which 0 times anything is going to be 0. And you'll know that the parabola comes down some way and comes back up right here. So big thing to know is you can always find the x-intercepts of a parabola by putting this in factored form. That's what you want to do there. One thing to point out here as well that I've had students ask me about in the past, you know, every single one of these, if you multiply them out, I think every one of those, if you multiply them out, it's going to equal your original expression here. They all are equivalent, but the key was the equation did not show the x-intercepts. You didn't see the 2 or the 4 in any of these top 3 equations. Only in the bottom one here is where they were visible in the equation. So be kind of careful that you're not just trying to get it to match up to be equivalent. All right, number 8, story problem here. In a video game, each player starts a game with K points. You lose 2 times every time you don't complete a task, and you gain no additional point. If a player who gains no additional points and fails to complete 100 tasks has a score of 200, what is the value of K? All right, so let's kind of take a look at this. I'm sure there's a couple different ways that we can do it. So I'm starting the game off with K, so I'm going to just kind of write a K there. And then I lose, so I take away 2 points every time I do not complete a task. So I lose 2 points every time a task is not completed. And it says if a player who gains no additional points fails to complete 100 tasks, well, so I lost 2 points times 100 tasks. So that means I lost 200. And I ended up with a score. At the very end, it says you end up with a score of 200 points. So what did I start with? Well, the only number that could work there is I must have started with 400 points in order to end up with 200. So the correct answer there is D. Number 9, looks like we have some sort of system of inequalities. System because there's 2 lines, and inequality because I don't see any equal signs in there. A worker uses a forklift to move boxes that weigh either 40 pounds or 60 pounds. So we have 2 different size boxes. Let X be the 40-pound boxes. And let's let Y, so I'm going to do a different color here. Let's let Y be the 65-pound boxes. The forklift can carry up to either 45 boxes or a weight of 240 pounds. Now, this word carry up to, that means that I got to stay less than, or equal to. All right? Otherwise, it's too much weight and it can't carry that much. So let's kind of try to put this together. So there were 2 restrictions. One, the forklift can only carry up to 45 boxes. Well, X is the number of boxes I have at 40 pounds, plus Y is the number of boxes. I'm not really worried about the weight here, but I have X many boxes plus Y many boxes has to stay smaller than or equal to 45. So that's part of it. So that right there, I think we wipe out C and we wipe out D. So now we have it down to A and B. Now, if you think about the weight, it's 40 pounds multiplied by every box. You know, so like if X is the number of them, say I have 10 of them, well, that's 400 pounds. So I do 40 times the number of those plus 65 times the number of Y has got to be less than or equal to 2,400. So I believe that matches up really nice with A. B actually divided the number of boxes by 40, which you're not going to get the right answer if you do that. And you could have just picked kind of some of your own numbers. But typically when you set up a system of equations, one of them is going to involve just the quantity. And then the other one for this equation, it involves weight. Sometimes it involves money. But I usually kind of break them up like that when I show strategy for system of equations. And I have a whole separate video just focusing on those. Number 10 looks like we're dealing with function notation. Function notation can be pretty tricky. A lot of my students really struggle with this. I think you'll find this problem is not that bad once we look at it. But a function kind of works like this. You have some sort of machine. You know, let's just call this is the F function machine. And it's programmed a certain way. It might multiply a number by 2. It might times it by 4. It might subtract 7. Who knows? But basically, you have an input. So like how I interpret this first piece right here, this basically says that in the function machine, I have an input, or I drop into here a 2. Something happens to it. I don't know what happens to it. And then the output, what pops out, is a 3. So maybe the machine was +1. I don't know what, I don't really need to know what the machine did, what the computation was, but I know I put a 2 in, I get a 3 out. I also know that if I put a 3 in, out pops a 5. All right? And then there's some other G machine here. There's some other G machine that when I put a 3 in the machine, out pops a 2. And then when I put a 5 in the machine, out pops a 6. So now what they're asking here is they're saying, what is the question starts here. It says, what is the value of f of g of 3? All right? I guess I have an extra parenthesis there that I really don't need. I'll just kind of get rid of that. There we go. Well, you always want to start on the inside. So this is really, f of something. And what my first job is, what the heck is g of 3? Well, we were told earlier, when I go over here to the G machine, when you put 3 in, a 2 pops out. And they told me right here also, they said, hey, g of 3 equals 2. So I'm going to substitute 2 in place of g of 3. And now the question is, well, what is the f evaluated at 2? Well, they tell me right here, f evaluated at 2 equals 3. Or if I come over here to my f machine, f at 2 comes out to be 3. So it's really just kind of understanding the terminology. You really didn't have to draw those boxes. I was just kind of trying to break it down for you. But you pretty much could just follow right through the paragraph up above. If you just kind of focused up here and you just said, hey, what's g of 3? Well, g of 3 equals 2. And then just stick a 2 right there. And then just say, well, what is f of 2? Well, right there it tells me f of 2 gives me an answer of 3. So you really didn't need to do the drawing.